Bishop Academy Books. Presenting The Children's Encyclopedia by Arthur May.
Beauty crowds upon us all our life in nature's wide kingdoms. The old idea that beauty is exceptional and to be looked for, especially in such plants as orchids, has almost disappeared. Many orchids are, indeed, resplendent and often strangely suggestive of butterflies, but one cannot say that they greatly excel some of our common flowers. The violet, the butterwort, the bogbean, the bladderwort, the grass of Parnassus, the bog pimpernel, and the daisy. The fact is that beauty crowds us all our life if we keep in touch with wildflowers, and this is a fact not less important than the statement that the central secret of the green leaf is being a sunshine trap. We have not learned much botany unless we've come to feel the beauty of common plants. The poet Keats said that throughout his life nothing moved him more than the opening flowers, and there is something wrong with us and with our science if we do not feel the wonder of the crocus breaking through the sod. But it is worth our while also to discover thrills, to follow the stream up the gorge, till we find the royal fern glistening with spray beside a waterfall. We are accustomed to think of strength in connection with animals and machines that move quickly about and do things and withstand assaults. The elephant, the railway engine, the lighthouse show strength, whereas we are inclined to think of the tender plant, the bruised flax, the short-lived grass, the poppy which is broken by being plucked. As everyone knows, many of our gay garden flowers are annuals, lasting only for the summer. But this is only one side of the picture. The grass withereth and the flower fadeth, but after all, the grass is one of the most successful of all living things. It has covered the earth like a garment. This power of spreading and multiplying is all very well when the plant is on man's side, as most grasses are, but when it is an injurious plant that spreads like bracken in this country, or prickly pear in India, then we see the menace there may be in the strength of plants. We are often impressed by the weightlifting feats of the strong man at the show, but have we done justice to the quiet strength of the forest trees, which are continually sustaining enormous weights against gravity, every year adding to their burden and lifting it higher? We know the explosive power of dynamite, but it is very interesting to see the roots of a tree spreading within a cleft in the rock and ending by rending it asunder. We know of the great transformations of energy which go on in chemical and engineering works, but we must do justice to the intensity of the operations that continue unceasingly through the summer day in the chemical and physical laboratory of every green leaf, and all without a sound. What strength of a sort there is in the way that microbes multiply, killing a man in a few hours. If one bacillus of the plague gets entrance into man through the bite of a rat flea, it may be represented by 1,000,000 the next day. What strength of renewal there is in many plants. The hawthorn is all the more vigorous because of the hedgeman's savage pruning. Then there is the strength of longevity, for the oldest living thing in the world are some of the big trees of California, which may have lasted for 2,000 years. One of our poets is responsible for this magnificent exaggeration: "Thou canst not stir a flower without troubling of a star." It is but a striking way of saying that no plant lives or dies to itself. Every one is the intersection of numerous threads in the web of life. Let us gather a few illustrations of the part plants play in the natural kingdom. First, there is the work of plants in the circulation of matter. As we have seen, green plants feed on air, water, and salts. They use the carbon of carbon dioxide as the basis for manufacturing the essentials of life known as starch, sugar, fats, and what are known as proteins. Some animal eats the plant or part of the plant, and another incarnation begins. For the nutritive material obtained from the plant, the nectar the bee changes into honey, the nut the monkey cracks, becomes part and parcel of the animal's body. It is incorporated in some measure into the animal's living matter. As the animal lives, it gives off carbon dioxide, and this carbon dioxide, when it again enters the atmosphere, may be absorbed by a green plant. Other forms of waste from the animal pass into the soil and may help to form salts which the roots of the plants may absorb. Some may pass as ammonia into the air, and this may be washed down by rain into the soil, to be again recaptured by the roots of plants. Or when the animal dies and sinks to the ground, bacteria begin to work on the dead body and it rots. Its complex substances are broken down into simple substances such as carbon dioxide, water, ammonia, and some salts. Out of a dead bird on the ground, the bacteria make materials which plants can utilize. Bacteria act as a middleman between the dead animal and the living plant. They make the materials of the dead body fit to enter again into the cycle of life. If we pay an early morning visit to a great fishing port such as Hull, Grimsby, or Aberdeen, we see what look like miles of fishes laid out for sale. We get a glimpse of the harvest of the sea, and the question arises, how is man able to take so much out of the sea year after year when he puts in so little? If he did this on a farm, there would soon be exhaustion of the soil, and he obviates this on land by putting in manure. But what happens in the sea? The answer is partly to be found in the vegetable sea dust, which is wafted outwards and downwards from the shallow water, where seaweeds and seagrasses flourish abundantly. Minute particles worn off by the breakers or nibbled at the animals are washed down the slope and form the food supply of fishes or animals, worms and mollusks on which fishes feed. It takes 10 pounds of this vegetable sea dust to make a pound of worms. But the other half of the answer is to be found in what biologists once called the floating sea meadows of the open sea. Countless millions of diatoms and other minute algae form a sort of living sea soup at or near the surface of the open waters. These minute organisms depend on the air and the seawater with its salts. In the sunshine, they go on with their work of building up life from light. Like the leaves of the forest, they and some minute green animals form the fundamental food supply of small crustaceans. And these again are devoured by fishes. The earth is run on a plan of successive incarnations, something like this. Air, water, and salts are absorbed by green plants in sunlight. Nutritive carbon compounds are built up out of these and are eaten by animals. The animals die and their dead bodies are destroyed by bacteria. From the decay of these bodies, gases, water, and salts are formed. These are absorbed by green plants again, and the cycle of life begins. A great transformation of energy is always going on in plants. The plant is a laboratory of complex chemical substances, and each has its own peculiar chemical routine, as every chemical factory has. But this work of building up could not keep going without help from outside, and it is the green plant's special secret to obtain this from the orange-red rays of the sunlight. The energy of the sunlight is used by the plant to help it in its manufacture of carbon compounds, which have chemical energy just as gunpowder has. Thus, there is a continual changing of kinetic energy into potential energy. We see the same thing when the kinetic energy of a rush of water is used by a hydraulic machine to raise a heavy weight to a height where it has energy of position or potential energy. But what takes place in the green leaf is a more intricate transformation and not yet fully known. We shall have to do with many other between things or linkages. Thus, one plant may unconsciously play into the hands of another, and when the dodder gets both support and food from the nettle, or when the mistletoe gets support and watery sap from the apple tree, or when an algae joins with the fungus to form a double plant or lichen, or when the root tubercle bacteria joins with the clover and enables them somehow to utilize the free nitrogen of the air. On another line are the linkages between flowers and their insect visitors, which secure fertilization, and the linkages which secure the scattering of seeds by fruit-bearing, eating birds. But we have made a good start towards understanding the relations which bind plants to the rest of nature.